All right, guys. Well, we are back, and we have our last section before a test, section 11.9. And the good thing is there's no new ideas per se. It's just combining ideas you've already learned. Okay, so be encouraged by that. And here we go. We're going to finish up with back to probability. All right, you got to notice that whether the problem says how many ways, that is not a probability question, right? Versus find the probability of. Okay, so now we're going to use the new skills, the new calculator buttons that you learned in 11.7 and 11.8. I hope you feel very comfortable with permutations versus combinations. Okay, and this section focuses only on combinations. So this is the last idea that you need to add, and there's a lot of things. Boy, 9 sections. Well, not really 9. We skipped a few, but still a lot of ideas. Okay, all right. So basically, we just jump right in and work through like 4 or 5 problems. That's all we got to do tonight. Okay, or whenever it is you listen to this. All right, here we go. Example 1. A club consists of 4 men and 5 women. 3 members are to be selected at random to form a committee. What's the probability that the committee will consist of 3 women? All right, so let's underline a few key ideas. First of all, our club has 2 parts to it, right? It has 4 men and 5 women. And this is a probability question, which means it's a ratio, right? So we could kind of write this out. The probability of 3 women. Now, just in words, okay? This will be the number of ways. That should sound familiar, right? Number of ways. Or let's just write it this way. How about the number of 3 women clubs? In other words, just the clubs that have 3 women. Okay? And the bottom is the total. Remember, in a probability problem, the bottom is always the total. Total number of 3 person clubs. So if you got to think back, right? It's been a couple weeks now. The top is always the desired outcome. In this case, it's a committee or a club of 3 women. Okay? And I guess just so I don't confuse you, I probably should call these committees. So there's a club of people, and they're making a committee. All right, let's kind of get our words straight here. So we want 3 women committees. Versus a total number of 3 person committees. Okay, so the top is only women, and the bottom is men and women. Okay? So I would say let's do the bottom first, because the bottom is always very general. In a probability, it's all the possibilities, right? So I'm going to switch to the next slide. I don't know if that's a good idea. You can't see the problem. All right, we'll make it work. So let's look at the bottom. The total number of 3 person committees. And this does not care about any specifics. It's just the total number. Okay? Now remember, a committee is a group. So we're going to be doing combinations or permutations? Combinations, right, because we're doing committees. We're not arranging the people. We're just putting them on the committee. So what's the total number of possible three-person committees? Well, that would be a combination. How many do we have to pick from altogether? 9, right? And we're picking how many? 3. So that would be the bottom. Okay? Now, the top. I'm going to switch to the next slide, and I want you to remember that if we're going to guarantee 3 women committees, how many women can we pick from? 5, right? Can only have 5, right? We can't be the committees that we want don't have any men on them, so we can't pick from them. Just 5 women. And we're still forming groups of what? 3. So, the number of 3 women committees are going to be a combination. How many women were there? You can actually just look back. 5. And how many are we picking? 3. Okay, so that's how many 3 women committees. So now we're back to our final problem, or our final question. The probability of picking a 3-woman committee is, what is it? The number of 3-woman committees, which we just figured out, over the total. Okay? All right. So the total was combination of 5, pick 3. Those are the women only, right? There were 5 women to pick from, and I picked 3 of them. Okay, that's going to guarantee me 3 women committees. That's the top. The top is always a desirable outcome. The bottom is the total. What was the bottom? Combination of 9, pick 3, right? Okay, so that's all you have to show me. Okay, and now at this point, we want to go ahead and work this out. So I'm going to grab my calculator. And at this point, you guys are pros, right? You guys are pros, so you don't even have to have me switch screens and go to the calculator. But hopefully you have your calculator and you can work this out with me in real time. I'll just go ahead and work it out, and then I'll give you the numbers to check. So 5C3, that's going to be 10. And 9C3 is 84. And that answer is just fine. You don't need to worry about a decimal. Don't worry about simplifying it. I mean, I guess you could give me a decimal if you want, which would be what? 10 divided by 84, 0.119, or an approximately 12% chance. 12% chance. If I put all 9 names in a hat, and I picked out 3 people, okay, there would be a 12% chance that I would pick I'd pick 3 women in a row, okay? That would be very unlikely. So there you go. Not too bad, right? Remember, probabilities, top and bottom. All right. Let's look at this one. Oh, yes. DVDs, home at school, kids home. Probably running out of DVDs. You guys are probably going through every possible kids show on Netflix there is. Jennifer has 4 Scooby-Doo, 5 Magic School Bus, and 3 Bob the Builder. All right. Randomly selects 4 for her children to take on a road trip. Determine the probability that no Scooby-Doos are selected. No Scooby-Doos are selected. Okay. Remember it said probability. So, I mean, I could just throw a P in front of this and that's our problem, right? Probability of no Scooby-Doos selected. Well, what I like to do is the bottom first. So, that's going to equal let's do the bottom. Well, the bottom is the total number of 4 DVDs possible. Don't worry about the top. Okay, just do the bottom. The bottom is the total number of 4 DVD groups. Again, we're not sorting them. We're not putting down our favorites. This is definitely a combination. Okay, we're not ranking them, just picking 4. Randomly picks 4. Okay, so the bottom is always the total number. So we're doing groups. So we're doing combinations. So how many total DVDs are there? 4 plus 5 plus 3. You got 12, right? And how many are you picking? 4. Okay, so that's the total number of groups of 4 possible. All kinds of variations. Now, if for your sanity sake you can't stand Scooby-Doo, so unknown to your kids, you kind of pull them out of the mix, right? Well, if you pull the Scooby-Doo out of the mix because you don't want to take Scooby-Doo, you want to make sure there's no Scooby-Doo selected. Well, if you take out the 4, how many are left? There's only 8. Okay, and how many DVDs are you picking for the trip? 4. So remember, in a probability problem, the top always takes into account whatever restrictions or whatever desires you have on the outcome. The bottom is always neutral. The bottom is always total. So the bottom is total groups of 4, and the top is groups of 4 that will not have Scooby-Doo, right? 12 minus the 4. Okay? Not too bad, right? So go ahead now and calculate that. I'm doing it too. So the top is 8C4, 70 different groups of 4 possible. Still a lot of options. In the bottom is the total number of groups of 4. 495. And what's 70 divided by 495? That's about 0.14, or you have a 14% chance of that happening. Okay, 14% chance of that happening. How you doing? Okay? I hope so. I really do. Really do. All right, we've got 3 more. I'll probably do this problem, and then I'll probably stop the video just so it's not so large and I can work with it quicker, and then I'll come back and do the next 2. So we'll probably do 2 videos this time. Okay? So we'll do this one, then we'll stop. And I'm going to have you help me out with this, so I might have you pause the video a couple times and then come back and see if you got it right. Okay? So this is pretty similar. Still doing Scooby-Doo, Magic School Bus, Bob the Builder DVDs. And what do we got this time? Jennifer randomly selects 4, so nothing's changed. Now you want to know the probability the probability that 2 Scooby-Doos and 2 Magic School Bus DVDs are selected. Oh, so this one, was not specific at all. It just said any combination of Bob the Builder and Magic School Bus. Okay, so that it just was one group, no restrictions. Okay, this one is a little bit different because look what it has. The word "and," meaning it's a specific type of group. A specific type of group. Okay, we'll come back to that. So let's do the bottom first. So the bottom is always the total number of groups. So it's not going to change from the last time, because what is the total number of DVDs to pick from? Still 12. And how many are we picking? Still 4. Didn't change. Didn't change. Okay? Now, I'd like you to pause the video, see if you can figure out what the top would be. We've done ones like it, okay? And then come back and check. Okay, so go ahead and pause, and I will wait. Okay, you're back. So hopefully when you saw the and, you thought, oh, two-part combination. Still a combination, not ranking, not arranging. The order doesn't matter. Still combination, but it's a two-part combination. So as soon as you see the word and, I hope that you wrote times. Okay, let's do the 2 Scooby-Doo DVDs first. If my group of 4 DVDs has to have 2 Scooby-Doos, it must. Well, the first part of my group would be picking, how many Scooby-Doo DVDs are there? 4. And how many am I picking? 2. So that will be the total number of 2 Scooby-Doo DVD groups possible. All right, 4C2. Along with that, I want to do Magic School Bus, and I want 2 of those. Well, how many Magic School Bus are there? There's 5. Okay. And how many am I picking of that? 2. Okay. Now, I would say be careful on this. You might want to put this in parentheses. You might want to put this in parentheses, just to make sure your calculator does not throw you off. All right? So why don't you go ahead and calculate that? I assume maybe you already did. I don't know. Let's see. So the bottom is going to be the same number as before, right? So the bottom is going to be 495. That's easy. And the top is going to be 4C2, which is 6, times 5C2, which is 10. So we got 60 over 495, which again is just fine for an answer, but if the book simplifies it and you want to know if you got it right, it's 0.12, 0.12, 0.12. So there you go, 12%. That was, yeah, the other one was 14. Pretty similar. Okay, I'm going to stop this now and pick it right back up with the last 2 problems, and that'll be called part 2 of 11.9. Okay? See you in a minute.